Students, in continuation, let's see resistance, right? So resistance is equal to voltage by current, right? R is equal to V by I, voltage by current. Okay. So physically, on what factors does resistance depend, right? So resistance of a conductor, it's the property of a material which opposes the flow of electric current, right? So let's see, the resistance of a conductor depends on, we can write, let's write the resistance of a conductor. The resistance of a conductor depends upon, the resistance of a conductor depends upon, number one, students, depend on the shape. Shape means what? Its dimensions, right? Shape means it dimensions. Dimensions or what material is, because every material is not having same atomic configuration, right? Intermolecular force is not same, atomic configuration is different. So it also depends on nature of material, right? Then in some materials also they're not pure, impurities, and what is the level of impurities on that also it depends. It also depends on the impurities. It also depends on the impurities, right? Then number four, it also depends on the temperature. Correct. We'll see one by one how it. If a conductor increases with impurities, then the resistance of conductor also increases because it will be getting more obstruction due to the other impure material in the pure material. Copper you are taking, right? The resistance is 10 ohm. I'll be adding some impurities. That means I'm adding some foreign material, extra material. So it will not let the electric current to pass through them. Means edge, जब हम copper लिए थे उसी के अंदर में जब वाइब्रेशन जिस तरह से हो रहा था, जब हम इम्प्योरिटी डाल देंगे तो अलग सा मटेरियल आ गया, तो इम्प्योरिटी इतना आसानी से नहीं जा पाएगा इलेक्ट्रॉन्स, तो रेजिस्टेंस इंक्रीज करेगा। तो इसीलिए हम एक पॉइंट बना सकते हैं, द रेजिस्टेंस ऑफ ए कंडक्टर, राइट, द रेजिस्टेंस ऑफ ए कंडक्टर increases with impurities, increases with impurities. Correct. But students, another one important thing, just keep in mind here now, we'll see how it happens. Resistance of a semiconductor decreases with impurities, जो कि हमारे लिए अच्छा है, मतलब एक पॉइंट पे हमारे लिए impurities ऐड करना भी अच्छा होगा, वो हम देखेंगे जब हम सेमीकंडक्टर पढ़ेंगे, राइट? So raise the resistance of a semiconductor, the resistance of a semiconductor decreases with impurities, decreases with impurities, right? Understood? Now let's see factors affecting the resistance of a conductor. Give hearing, students. Factors affecting, right? Factors affecting the resistance of a conductor. Factors affecting the resistance of a conductor, right? Right, factors affecting the resistance of a conductor. See, students, number one, students, let I have taken a long conductor. What happens in case of a long conductor? Long conductors means more number of electrons, but the area is specific. Let I am taking a wire like this. So long road means there is a probability of increasing the resistance. So resistance of a conductor, student, increases directly with length, because more length means more number of electrons, but there is not that much space to undertake the vibrations, right? But अगर ये थोड़ा मोटा होता है यार, तो वायर अगर थोड़ा थिक होता, राइट, तो वाइब्रेशन जो है थोड़ा, मतलब अब देखिए एक नैरो रोड है, उसमें बहुत सारे व्हीकल्स जा रहा है, और एक वाइड रोड है, बहुत सारे व्हीकल्स जा रहा है। कहाँ पर एक्सीडेंट का चांसेस ज्यादा है? जो नैरो रोड है, क्योंकि आराम से नहीं जा पाएगा। वाइड रोड में क्या होता है कि साइड में जगह होता है, व्हीकल निकल जाता है साइड से। गेटिंग माय पॉइंट और नॉट? तो इसी के लॉजिक से हम ये बता सकते हैं, तो रेजिस्टेंस ऑफ ए कंडक्टर इज डायरेक्टली प्रोपोर्शनल टू लेंथ, राइट? लेट दिस इज लेंथ ऑफ द कंडक्टर and this is area of cross section and this is length. More the length, more the resistance, correct? So you can also write in some numericals, R1 by R2 is equal to L1 by L2. We'll see that one by one. We'll see all the applications. You'll be getting questions on that, right? Student, कभी कभी क्या होता है कि small change in resistance. Let R is proportional to L. So for small change in length, right? For small changes in length, correct? Change in resistance by original resistance is equal to change in length by original length, right? Delta R by R is equal to delta L by L, correct? Understood, students? And the second point, the resistance of a conductor is inversely proportional to area, right? And area of a conductor, that means it's a circular part. If the radius is R, so the area is proportional to area is equal to what, students? Pi R square, right? So area is proportional to radius square. So you can write, also you can write radius is proportional to 1 by R square. So if I'll be taking R1, let two conductors I want to compare, R1 by R2 is going to be not A1 by A2, that is going to be A2 by A1, right? And A2 means pi R2 square. So we can write here R2 square, radius of the area of the second conductor, and R1 square. Are you getting, student? You are going to get numericals on this, right? Understood on? And student, for small changes in area, right? For small changes in area, right? For small changes in area or radius, we have, students, binomial theorem, square is multiplied by 2 times, right? Delta R by R is going to be delta A by A, change in resistance, that is equal to R square. So in small binomial theorem, 2 delta R by R, you can write like this, radius and how area for the small changes. We'll be doing numericals on this sort, right? And so another one thing, as the temperature increases, the resistance of the metallic conductor increases, right? So resistance is directly proportional to temperature. More the temperature, more the resistance. T is temperature. We'll see what is the temperature dependence of resistance, right? And student, there is another physical quantity that is known as conductance, right? That is reciprocal of resistance, right? Conductance. Conductance is nothing but it is the reciprocal of resistance, right? Symbolized as G. So it's the reciprocal of, right? It's the reciprocal of resistance. Correct, students? And G is equal to 1 by R. So its unit is going to be what, students? Ohm inverse, mho or Siemens or ohm inverse, right? So अगर हम इसकी unit की बात करेंगे तो it is going to be ohm inverse, right? Or you can write MHO, or you can also write Siemens. Are you getting all? Then another quantity, students, from your early classes, high school level classes, were acquainted with this term, that is resistivity, right? Resistivity, or it's another name is specific resistance. Specific resistance, right? It's resistivity or specific resistance. Okay, students? Students, from the above two cases, you got to know resistance directly proportional to length, right? And resistance is inversely proportional to area. So combined, you can write R proportional to L by A. Correct or not, students? So there is something proportionality constant, that is R is equal to rho L by A. This rho, this is not density, this is resistivity, right? Rho is called specific resistance or resistivity, right? Rho is called specific resistance or resistivity of the material of the conductor. Specific resistance or resistivity of the material of the conductor. Right? What, students? So let's know what resistivity is, right? So resistivity means what? I am specifying the resistance. In what terms? In terms of dimensions, right? I will be taking a conductor, correct? I'll be taking a conductor over here. and its length is L, its radius is R, correct? Or that means its area is A. But the length I have taken as 1 centimeter or 1 meter, and the area I have taken as 1 centimeter square or 1 meter square. That means you know R is equal to, you got to know rho L by A. That means if L is going to be 1 and this is going to be 1 meter and this is going to be 1 meter square or centimeter square. So in that case, R is going to be rho. Yes or no? Isn't it? That means I am specifying the resistance in terms of its dimension. That is, I have taken a conductor whose length is 1 meter and its resistance is going to be 1 meter square, or length is 1 centimeter, or the resistance is going to be 1 centimeter square. Getting, students? That means specific resistance of any material. मैंने आपको बताया कि what is the specific resistance of copper. So you'll be asking me, sir, give me 1 meter length. मुझे एक 1 meter length की copper wire दीजिए, right? जिसकी area of cross section, sir, how much will be its area of cross section? Sir, its area of cross section is going to be 1 centimeter or 1 meter square. 1 unit will be taken. So in that case, the resistance offered by that is known as the specific resistance of copper. Are you getting all, students? The specific resistance of any material is defined as resistance per unit length, right? This is resistance per unit length per unit cross-sectional area. Resistance of that material. Resistance of the material having unit length and unit cross-sectional area. Having unit length and unit cross-sectional area. Unit length and unit cross-sectional area. Understood, students? Understood or not? Till now you understood this. There is nothing new. You know all those things, right? And student, resistivity depends. Resistivity is independent of dimensions of the conductor. मैंने copper बोल दिया मतलब मैं वो उसको specify करके ही बोल रहा हूँ. I'm saying the specific value of resistance, right? And student, resistivity of an alloy is more than resistivity of its constituent elements. अगर मैंने आपको बताया कि कोई भी एक एलॉय आप ले लो और उसके जो मिला हुआ मटेरियल है उसके रेजिस्टेंस से उसका रेजिस्टेंस ज्यादा है, रेजिस्टिविटी ज्यादा है, राइट? And resistivity depends on the nature of the material of the conductor and temperature and also impurities. तो एक पॉइंट यहाँ पर आप ऐड कर दो, resistivity, right? Resistivity depends on the nature of the material. Depends on the nature of the material of the conductor. Nature of the material of the conductor, right? And also depends on temperature, underlying temperature, and depends on impurities. Because अगर ये सारे चीजें भी रेजिस्टेंस के ऊपर डिपेंड करता है, अगर रेजिस्टेंस के ऊपर डिपेंड करता है तो डेफिनेटली रेजिस्टिविटी भी उसके ऊपर डिपेंड करेगा, राइट? और एक चीज यहाँ पर लिख दो, रेजिस्टिविटी ऑफ, राइट, रेजिस्टिविटी right, resistivity of any alloy, resistivity of any alloy is more than resistivity of its constituent elements. Resistivity of its constituent elements. Right? So R alloys is greater than R conductors. Right, students? R alloy is greater than R conductors. Students, let I'm saying some linked things on the resistance side, giving special cases. Just keep the notes, and these notes will be available in the Telegram also, right? It will help you. All the notes will help you in solving any numerical. So I'm giving you point wise so that any numericals you can do this of your own, right? the alternate forms of resistance. Students, see, you wrote resistance proportional to, or let not proportional to, resistance is equal to rho L by A, right? So do one thing, multiply a L on the numerator and multiply a L in the denominator. Students, it is going to be the rho into L square by volume, yes or no? Are you agree, students? Agree or not? It can be rho L square by V. Students, area into length, volume, yes or no? So next, student, density is equal to, I'm writing D because rho I have already used for resistivity. So density is equal to mass by volume. So in place of mass, what can you write? Mass by density. So here you write, by seeing this one, you can write here rho resistivity into L square divided by mass by density. So it is going to be rho into L square into D by M. Are you getting, student? So that means we can write resistance is equal to resistivity, right? Resistance is equal to, actually this is volume. Volume is equal to mass by density. So we wrote mass by density. So you can write here, students, you can write density is equal to mass by volume. So volume is equal to mass by density. You put your mass by density, right? So rho L square. Actually, I want to replace L square also. Students, can I replace L square? How to replace L square? Just see. Are you getting all or not? Okay. You got a case, resistivity into L square into density by mass. This is one form of resistance. Are you getting all? Correct. Next, let's see another form. Another form means I want to relate it in some other ways, right? R is equal to rho L by A. So do one thing now. You multiply A in the numerator and you multiply A in the denominator. How it can be related? I mean, sometimes you have to fix the length fix. Sometimes you have to make the area fix. How to do that? Let's see. So that is density into LA by A. Students, see here. On the top it is volume, on the down it is area. Correct or not? And here you know volume is equal to mass by density. So in place of volume, you can write mass by density, correct? Divided by area. So that is going to be resistance is equal to rho into M by density into area into area. We have not multiplied area here. Are you getting my point? So it is area square. Another form of resistance, students, you got? Got or not? So what is D here? D is density of material, right? Density of material. And so what is V here? Volume of conductor. And what is M, students? Mass of the conductor. When you will get the questions, you will see what happens in which case, and accordingly you can solve the questions. Got, students? Then another thing. You will get some question where it will be given the conductor is stretched, elongated, drawn, twisted, whatever you'll be doing with the conductor, what remains same? Same? The volume remains same, correct? Getting my point now, students? Some question you will be getting, like just right. If a conductor is stretched or elongated, देखो स्ट्रेस्ड लिखा होगा, elongated लिखा होगा, और drawn मतलब हमने इसको खींचे, drawn, और कहीं कहीं भी twisted लिखा जा सकता है. ये कुछ भी केस हो, right? Then what remains constant, student? The volume of the conductor remains constant, right? Then the volume of the conductor, is constant. The volume of the conductor is constant, right, student? So volume of the conductor constant means, students, just now we got a formula R is equal to rho L square by V, correct or not? Volume is constant. Specific resistance is a constant. So in that case, you can write R proportional to L square. We can use this link or not? Getting or not, students? Another bit. Resistance proportional to, you got rho not equal to, you take then it is a constant. Rho V by S square you took. Yes or no, students? Rho is constant, V is constant. So you can write R is proportional to 1 by S square, or R is proportional to R to the power 4. If volume is constant, getting my point or not, students? Sometimes in terms of mass, right? In terms of mass of the wire. In terms of mass of the wire. Right? R proportional to L square by M. Are you getting, student? That means you can write R proportional to M by S square, or that is also M by R to the power 4. Are you getting my point, student? These things will be utilized in the numericals that I'm going to give in the test and in the assignment too, right? And एक point यहाँ पर आप add कर दो, for small changes in the length of the radius, right? For small changes in the length, for small changes in the length or radius during the stretching, so change in resistance by resistance is equal to 2 delta L by L. That means delta R by R is equal to, students, length is increasing, right? Inversely proportional to area. So that was minus 2 dl by A. So inversely, so that's why negative, right? So delta A by A, that is अगर हम radius के साथ लिखेंगे तो minus 4 times delta R by R. You'll be getting all those things in the question. Just keep in mind the synopsis, right? I'll do numericals on that. Students, another one thing, see here. Let's we'll be doing a cuboid, right? There is a cuboid of dimensions LBH. Cuboid of dimensions length into breadth into h height, right? That means it's like this. एक cuboid बना देते हैं. Correct. Just see how it happens. Correct. Student, let this is the length, right? This is the breadth and this is the height, correct? और मैं faces के नाम, ये जो एक face है ना, इसका इस face का नाम मैंने A दे दिया, और ये जो आपको एक face दिख रहा है उस face का नाम हमने B दे दिया, right? और दूसरा ऊपर में भी एक face है, students. इस फेस के नाम, पूरा इस फेस के नाम हमने क्या दे दिया, सी दे दिए, जो मैंने रेड पे किया, राइट? और नीचे में भी एक फेस है, इस फेस का नाम डी दे देते हैं. अंडरस्टूड स्टूडेंट? द नेम ऑफ दिस फेस इज डी, राइट? ए बी सी डी, चारों फेसेस आपको पता चल गया स्टूडेंट्स? गेटिंग और नॉट? मैंने अभी पूछा आपको रेजिस्टेंस अक्रॉस, राइट? नाउ आई जस्ट आस्क्ड रेजिस्टेंस अक्रॉस AB, that is RAB is equal to rho resistivity into L length by B into H. Understand students? R is equal to rho L by A. मैं AB के across पे निकालना चाहता हूँ ये दोनों end, मतलब ये लेफ्ट साइड और ये राइट साइड में, राइट? A और B के बीच में. तो मुझे किसका लेंथ लेना पड़ेगा? लेंथ, ये लेंथ लेना पड़ेगा. और एरिया जो है इन लोगों, इसका एरिया लेना पड़ेगा. ये जो है इसका एरिया लेना पड़ेगा मुझे. Are you getting student what I did like this? अगर मैं ठीक इसी तरह रेजिस्टेंस अक्रॉस CD निकालूं तो बता सकता है कोई क्या होगा? रेजिस्टेंस अक्रॉस CD is going to be how much? Rho into B by L into H. देखो ये जो डिस्टेंस हमने लिया ये क्या है? B है. और ऊपर का एरिया क्या है? ये H है, ये A है. तो इसका एरिया क्या हो जाएगा? L into H, राइट? Students, getting or not? Getting or not, students? और एक चीज देखो यहाँ पर, अगर मैं अक्रॉस ई एफ की बात करूं, मतलब ये जो नीचे वाला जो फेस है ना, मैंने ये जो सामने वाला की जो फेस है, ये जो फेस दिख रहा है ई, और पीछे वाला जो फेस दिख रहा है मैंने एफ ले रहा हूँ, राइट? गेटिंग माय पॉइंट स्टूडेंट्स? तो मैंने रेजिस्टेंस अक्रॉस ई एफ निकाला, मैंने जस्ट सी हियर, रेजिस्टेंस अक्रॉस ई एफ मैंने निकाला, तो क्या हो जाएगा, रो इंटू हाइट एच ले लिया डिवाइडेड बाय एल क्रॉस बी, ये हो गया ई एफ का, ये हो गया मेरा रेजिस्टेंस ऑफ सी डी, and this is resistance of AB. The students see here, where the area is less and the length is more. Because you know student, in the diagram length is greater than breadth is greater than height. हमने इस तरह से बनाया, right? Length is greater than breadth, length is greater than breadth is greater than height. So अगर हम maximum resistance की बात करें तो आप बताओ कहाँ पर होगा maximum, जहाँ पर length ज्यादा है, तो rho L by B into H, ये वाला हो जाएगा मेरा maximum जो हमने यहाँ पर निकाला फर्स्ट में। और आर मिनिमम कितना हो जाएगा स्टूडेंट, जहां पर लेंथ मिनिमम है, दैट इज आर मिनिमम इज इक्वल टू रो इनटू एच डिवाइडेड बाय एल क्रॉस बी। करेक्ट और नॉट स्टूडेंट्स? गेटिंग ना स्टूडेंट्स? आर यू गेटिंग ऑल? नेक्स्ट सी another point, let's add. Student, if a wire of resistance R, if a wire of resistance R is stressed to n times its original length, its resistance becomes n square r, students, right? मैंने n टाइम्स l के साथ डायरेक्टली प्रोपोर्शनल है l स्क्वायर के साथ, तो n स्क्वायर टाइम्स r हो जाएगा, राइट? गेटिंग और नॉट? नेक्स्ट, ये सारे पॉइंट्स याद रखना बहुत जरूरी है क्योंकि उसके बाद मैं आपको क्वेश्चंस दे दूंगा। इफ ए वायर, ठीक है स्टूडेंट, अगर मैं स्ट्रेच किया जब तक रेडियस 1/nth टाइम हो जाएगा, राइट? देन ओरिजिनल रेडियस, देन इट्स रेजिस्टेंस बिकम्स n टू द पावर 4, क्योंकि मैं इसको आधा कर रहा हूँ, मतलब उसको डबल कर रहा हूँ। कहीं पे अगर एरिया को मैं आधा कर रहा हूँ, दैट मींस मैं लेंथ को डबल कर रहा हूँ, राइट? तो स्टूडेंट, राइट, if a wire of resistance R is stressed until its radius becomes 1/nth of its original radius, 1/nth of its original radius, then its resistance becomes n to the power 4r, right? Just see, 1/nth कर दिया हमने, रेडियस को हमने हाफ कर दिया मान के चलो, तो लेंथ कितना हो गया, लेंथ डबल हुआ होगा, तो लेंथ डबल इधर से स्क्वायर हुआ, और फिर अब से एरिया भी आधा हुआ, इनवर्स प्रोपोर्शनल स्क्वायर, जब ऊपर जाएगा तो फिर डबल, तो n टू द पावर 4 हो गया। गेटिंग माय पॉइंट? रेजिस्टेंस को मैंने मान के चलो until its radius becomes half, मतलब देखो ये इतना मोटा था, मैंने रेडियस को आधा कर दिया और थोड़ा मैंने खींचा, राइट? इतना सा पतला कर दिया मैंने उसको, तो रेडियस मतलब मैंने स्ट्रेस्ड एंड द रेडियस बिकम्स हाफ, तो रेडियस हाफ हो गया स्टूडेंट, आर जो था r/2 हो गया। देखो, तो जो एरिया था, एरिया इज इक्वल टू पाई आर स्क्वायर था, अभी न्यू एरिया क्या हो जाएगा, पाई r/2 का स्क्वायर, दैट इज पाई स्क्वायर बाय 4, दैट मींस r is inversely proportional to L/A. Getting or not, students? Where of resistance R is stressed until its radius becomes half. its original radius, then its resistance become n square times ये जो 4 आया नीचे, तो ऊपर जाने के बाद एरिया 4 times कम हो गया, तो ऊपर जाएगा ना L by A, तो 4 times हो जाएगा. Are you getting students my point? ठीक है. और यहाँ पर और एक दो पॉइंट जो कि कभी-कभी बच्चों को कंफ्यूज करता है. Let's see that one, right? 7. Right, when a where, friends लिखो थोड़ा ये points. When a where is stressed to increase its length, by x%, right? So where x is very small, right? Where x is very small, its resistance increases by 2x. Its resistance increases by 2x%, correct? X% and 2x%, correct? Next 7, 8. Right, student? When a wire is stressed to increase its length by x%, right? Where x is very large, right? Where x is large, right? Its resistance increases by, right? Its resistance increases by, students, 2x plus x square by 100. Percentage निकालना पड़े तो इंटू करना पड़ेगा, right? Getting my point? This number 9, last part of the synopsis, then we'll do the numericals next class, right? Student, when a wire, right? When a wire is stressed to reduce its radius, stressed to reduce its radius by x%, right? Where x is very small. Its resistance increases by, its resistance increases by 4x%, right? Correct, students? Understood? Then I have a small thing we'll add here. Then we'll do the numericals in the next class, right? How the temperature, students, like resistivity, there is something conductivity also, right? Reciprocal of resistivity is known as conductivity. That is sigma. So it's like sigma is equal to reciprocal of resistivity. That is equal to 1 by resistivity was RL by A, right? So it will be how much? 1 by rho, right? Sorry, 1 minute. Should see here. R is equal to rho L by A. So L is equal to, so R is equal to rho L by A. So rho is equal to how much? R A by L. So that is equal to 1 by R A by L. So if L will go up, then it is L by R A, right? So अगर हम इसकी यूनिट की बात करेंगे student, if I'll be saying about its SI unit, right? SI unit is equal to Siemens per meter. That is Siemens meter inverse, right? And student, for perfect insulators, conductivity is equal to 0, right? For perfect insulators, conductivity is equal to 0. And for perfectly conductors, for perfect conductor, sigma is equal to infinity. Getting, students? Next, another one thing, temperature dependence of resistance, right? That we'll see in the next class. So this much for today, right? Next class we'll see temperature dependence.